Assalamualaikum everyone, we are from group 3 and today we are going to present about oil. Before we proceed, these are our group team members: Nur Syafiqah binti Kahar, Izzati Najihah binti Yusli, and Nur Hanis Najihah binti Ibrahim.
Okay, first of all, I will start with the definition of oil. Okay, oil is any non-polar chemical substance which is a viscous liquid at ambient temperature and hydrophobic and also can be lipophilic. Okay, there are two types of oil. Okay, first one is the organic oils. It's actually the one that are produced by a variety of plants, animals and other organisms through natural metabolic process. And the next one is mineral oil, such as crude oil or petroleum, which is the crucial resource nowadays that comes from the ancient fossilized organic materials such as zooplankton and algae, which geochemical processes convert into oil. Okay, the next one, I will explain about the molecular structure of oil. Okay, oil actually belong to a group of biological substances called lipids, and the structural formula shows that oil contains 3 ester functional groups, and this ester composed of 3 fatty acid units joined to form glycerol and a trihydroxy alcohol. Okay, the next point is the properties of oil. Okay, as the composition of oil is varies according to its type, they have a certain unique characteristic or properties. Okay, among the properties of oil that I will explain here is firstly the viscosity, which is the resistance to flow in a liquid, and next one is the density, meaning that the weight of a given volume of oil, and the density will be expressed in gram per cm cube or kg per meter cube. The next properties is the solubility. The solubility of oil in water is actually the measure of how much oil will dissolve in the water column on a molecular basis. Next one is the flash point. Okay. Flash point is the temperature at which the liquid gives off sufficient vapors to ignite upon exposure to open flame. And the next one is the interfacial tension, which is the force of attraction or repulsion between the surface molecules of oil and water. Lastly is the vapor pressure, meaning that the measure of how the oil partition between the liquid and gas phase. Okay, first of all is the oil viscosity. Okay, the viscosity of oil will decrease when the temperature is increased and will increase with decreasing temperature. Oil viscosity is the measure most commonly by kinematic viscosity in centi-Stokes units. Kinematic viscosity is the measure in time that takes for a specific volume of oil to flow through a special device called a capillary tube. Okay, the next is the density. Most oil will float in water because most oil density range from 0.7 to 0.99 gram per cm cube, while the density of water is 1 gram per cm cube. So that's how oil float on water, because the difference in density. Okay, the next one is the solubility. It focuses in oil in water. Okay, generally the solubility of oil in water is so low, which means that the less than 100 parts per million, that this would be equivalent to approximately 1 grain of sugar dissolving in a cup of water. Next one is the flash point. Okay, a liquid can be considered to be flammable if its flash point is less than 60 degrees Celsius. So all liquid have a specific vapor pressure, which is a function of the liquid temperature. When the temperature increases, the vapor pressure will increase. And as the vapor pressure increases, the concentration of vapor of a flammable or combustible liquid in air will also increase. Next is the interfacial tension, focused on oil and water. Okay. The lower the interfacial tension with water, the greater the extent of spreading. And water and oil are essentially immersible, and both liquids tend to separate into two phases. So the higher the interfacial tension value of the liquid, the two liquids will be more likely to separate. Okay. And then the decreasing the interfacial tension is essential to create a stable immersion between oil and water. And the last one is the vapor pressure. Okay, due to oils being a mixture of many compounds, the vapor pressure will change as the oil weathers. So the vapor pressure of oil is not entirely relevant because of the mixture of many compounds that present in oil.
So next, I'll continue to present about the processing of oils, specifically mineral oils. So mineral oils is produced from refined hydrocarbon obtained from crude oil by distillation method. So what is crude oil? Crude oil is a naturally occurring petroleum product that composed of hydrocarbon and deposits and other organic materials. It is considered as a limited resource since it is non-renewable form of energy, which means that it is irreplaceable at the rate we consume it. So we can obtain the crude oil through drilling, where it usually found alongside other resources such as natural gas and saline water. So the crude oil is extracted from the bottom of the sea and refined and processed to produce a variety of petroleum products such as gasoline, kerosene, and asphalt. It is also important resources because most people now depend on it to run newly invented machine and also any other working process. In refining process of crude oil, there are three major steps involved, which is separation, conversion, and also treating process. So in separation process, the molecules are separated through atmospheric distillation, for example at normal atmospheric pressure. And during this process, which is also known as topping, the oil is heated at the bottom of 60-meter distillation column at temperature 350 degrees Celsius to 400 degrees Celsius, which causes it to vaporize. And the vapor will rise inside the column while the heaviest molecules or the residuals will remain at the bottom without vaporizing. The molecules condense into liquid at different temperature in the column as the vapor rise. Only gases that reach the top where the temperature drops to 150 degrees Celsius. And the higher liquid are found in the column, they become increasingly light and are collected on trays located at different heights of the column. And each tray will collect at different petroleum fraction, which also known as petroleum fraction with highly viscous preservation, like asphalt at the bottom and gases at the top. And the heavy residuals left over after atmospheric distillation will still contain many products of medium density, but will transfer to another column where they will undergo second distillation to recover middle distillates like heavy fuel oil and diesel. So the next major operation of refining crude oil is conversion process. Even after separated, there are still many too heavy hydrocarbon molecules remain. So to meet demand for lighter products, the heavy molecules will be cracked into two or more lighter ones. So this conversion process is carried out at 500 degrees Celsius and also known as catalytic cracking because it uses catalyst as a substance to speed up the chemical reaction in the process. This process converts 75% of the heavy products into gas, gasoline, and diesel. Also, adding hydrogen will also increase the yield, and this process is called as hydrocracking. Or it can be increased by using deep conversation to remove carbon. And the objective of refining process also to find a balance between the yield and the cost of conversion. So, and the last major step in refining crude oil is treating process. In this process, it will remove significantly reducing molecules that are corrosive and causing air pollution, especially sulfur. This measure is taken to improve the quality of air and optimize the effectiveness of the catalytic converters that used to treat exhaust gas. For sulfur removal, it is performed at 370 degrees Celsius at pressure of 60 bar. Hydrogen also used in this process combined with sulfur to form hydrogen sulfide, which then will be treated to remove the sulfur.
Okay, next we continue with the analysis of oil. Conducting oil analysis will determine the system performance and reliability as well as the condition of the oil. So the analysis can be conducted based on fluid properties, characteristics, and contamination in the oil. There are several methods of oil analysis, but in this report we're going to discuss about the viscosity analysis, moisture analysis, and wear metal analysis. Okay, first is viscosity analysis. So what is viscosity? Viscosity is a measure of fluid resistant to flow. So a fluid with high viscosity have lower flowability. This is because the high viscosity resists motion due to greater friction when they are in motion. So the viscosity will allow us to analyze liquid behavior and also the fluid motion. And usually viscosity is measured based on kinematic viscosity and absolute viscosity. So what is absolute viscosity? Absolute viscosity is a measure of internal resistance to flow due to some shearing force, while for kinematic viscosity is defined as it resistant to flow and shear due to gravity. So how to calculate viscosity? So for absolute viscosity, we can calculate by shearing stress divided by shearing rate change. And for instrument, we can use rotational viscometer, where the viscosity is determined by measuring the force that is required to rotate the probe in the liquid sample. While for kinematic viscosity, we can calculate by the absolute viscosity divided by density of the oil. So these are the several reasons why we need to analyze viscosity. First is the excessive shearing and high temperature can result in the decrease of viscosity values and cause the oil being ineffective to operate in such condition. The second one is excessive shearing also lead to boundary lubrication condition where two surfaces are no longer achieving full fluid film, which is hydrodynamic and elastohydrodynamic. And the last one is the extreme temperatures, continuous heavy loading, shock loading, and degrade or mixed lubricant can also contribute to boundary lubrication condition and result in inadequate lubricant condition. So next is moisture analysis. So water content in oil is considered as contamination. This is because water content has potentially devastating effects such as rust, increased wear rate, and loss of additive functionality. So there are three types of water contamination, which are free moisture, emulsified moisture, and also dissolved water. So for dissolved water, this is characterized by individual water molecules dispersed through the oil. The moisture comes from ambient air humidity that slowly interact with the lubricant oil over the time. Next is the emulsified moisture, where the oil is saturated when the amount of water has reached the maximum level to remain dissolved. At this point, any added water will precipitate out as cloudy emulsified microdroplets. And the last one is the free moisture, where the free moisture is water that is neither dissolved nor emulsified within an oil sample but remain in a distinct and separate aqueous liquid phase. So for free moisture and emulsified water is the most harmful phase for lubricant system. So how to calculate moisture content? We can use crackle test, where in this test a hot plate is held at 130 degrees Celsius and a small drop of oil placed in the center. Any moisture present in the oil is reflected in the number of bubbles observed as the water vaporizes. Depending on the lubricant, relatively few small bubbles indicates approximately 500 to 1000 of water. Significantly more bubbles of a larger size may indicate around 1000 to 2000 of water, while an audible cracking sound indicates moisture level in excess of 2000 ppm. To add, the crackle test is sensitive only to free and emulsified water. So why we need to analyze moisture content? Water content has a potentially devastating effects such as rust, increased wear rate, and loss of additive functionality. Next is the amount of moisture in the product impacts its processability, shelf life, use, and also quality. And lastly, the presence of water can cause irreparable damage to the engine, machine, and system. So the last one is wear metal analysis. Wear metal testing identifies probable metal wear contamination in the parts per million, which is ppm range, and serve as an early warning system for potential equipment damage or failure. And it contains impurities from both internal and external source, as well as debris from own surface. Because of this, the machine should be evaluated time by time to avoid costly damage and downtime to high-value engine, gearbox, generators, turbines, and other critical machinery. So to determine the wear metal analysis, we can use spectroscopy. Spectroscopy helps to monitor contaminous metals and enable analysts to look for foreign molecules in the oil. The spectrometer capable to detect and quantify the wear metals and contaminants present in the oil sample. Usually we use Fourier transform infrared (FTIR) spectroscopy, is where it's specifically used for detecting degradation, dilution, or illegal additive in different types of oil. Mechanism of FTIR. The FTIR instrument sends infrared radiation of about 10,000 to 100 cm through a sample, with some radiation absorbed and some passed through. The absorbed radiation is converted into rotational or vibrational energy by the sample molecules. The resulting signal at the detector presents as a spectrum, typically from 4,000 to 400 cm, representing a molecular fingerprint of the sample. This produces useful molecular data and enables rapid identification of chemicals without the need for consumable or extra chemicals. The last one is why we need to analyze metal wear. So metal wear helps us to extend the life of engine and prevent any unexpected damage to the engines. Next is the early detection of wear metals in lubricants and grease, improve machinery reliability. And the last one is it will save money by avoiding costly damage and downtime to high-value engines, gearbox, generators, turbines, and other critical machinery.
So next, I will explain about the application of mineral oil used in industry. So So first, mineral oil is commonly found in skincare and cosmetic products. This is because mineral oil is highly purified, lightweight ingredient, which commonly used in baby lotion, cold cream, ointments, and many other cosmetic and personal care products. Also, it has the ability to help reduce water loss from skin, which keeps the skin moisturized. Mineral oil is also known as non-comedogenic, which means it does not clog pores. That is because of its highly refined and purified mineral oil, and also because of an inert and stable compound. So other than cosmetic and skincare products, mineral oils also have been applied in the manufacture of basic food pantry staples. For example, they were used as binding agent or lubricant in the yeast manufacturing process. They also can be applied to grains like wheat, rice, oats, and barley to keep from adhering of dust to the product. Other than that, mineral oils is also used in biomedical sections such as liquid paraffin, which is used as laxative to alleviate constipation by retaining water in stool and intestine. Even it's generally considered as safe, but there is a concern of misinhalation, which can lead to serious health conditions such as pneumonia. And mineral oils also produce a few of petroleum products such as kerosene, heating oil, diesel fuel, and also gasoline.
To conclude, oil is essential raw materials that have excellent properties to be used in daily life. The molecular structure and properties of oil determine its quality and applications, while the analysis of oil help to determine the system performance, reliability, and condition of oil. That's all from us. Thank you.